Hello there. In the spirit of YouTube kid from the middle school class, I decided to do a video. I even wrote a script. I'm an up-and-coming YouTuber, aren't I? Today, I decided I'm going to go into a theoretical world and throw stuff into a black hole. That's right, I decided instead of doing, the normal science experiment where you can map out like a procedure and a conclusion, I'm going to be going into a theoretical world, math and physics, and throwing stuff into a celestial body that I will probably, and hopefully, never come in contact with. First, what is a black hole? A black hole is essentially a giant cosmic hole that comes from large stars. Most of the time. Except we aren't sure how the supermassive ones form. The way stars work is that the energy from the inside pushes out while gravity pushes in. Many stars have ways of escaping becoming a black hole, and I'll give you a little history lesson to explain why. A lot of people didn't like the idea of black holes when Einstein's theory of general relativity predicted them. In fact, he didn't either. Most astronomers thought that somehow some force would keep stars from collapsing into a point like a black hole. Ralph Fowler came up with a possible solution to the problem of black holes back in 1926. Due to a lot of really complex scientific laws, as gravity crashes in on the star, its electron's velocity has to increase. So the more the star gets squished, the more and faster electrons wiggle around. This is what makes white dwarfs form, like Sirius B. However, in 1930, a 19-year-old named Chandrasekhar discovered that this couldn't hold up all stars, because electrons can only wiggle up to the speed of light. So only stars up to the Chandrasekhar limit, 1.4 solar masses, can be held up by wiggly electrons, called electron degeneracy pressure. However, when you squish a star even more, the protons and electrons fuse and make neutrons and neutrinos, whose degeneracy pressure is even stronger, so it can hold up neutron stars. Since people thought black holes were just too crazy to be real, they desperately tried to find ways of disproving their existence. But in the late 1930s, J. Robert Oppenheimer, the atom bomb guy, and George Volkoff found out that there's also a limit to how much mass neutrons and neutrinos can hold up. Sure enough, Oppenheimer and Hartland Snyder proved that some would have to collapse with nothing to save them. Thus, they became black holes, which are essentially really scary points of infinite mass and density, which trap light and bend time to their heart's content. How do we know where they are, though? They start eating stars and gases around them and warp them so it's evident where one is. Here's the problem with a lot of information on black holes, though. A lot of it is theoretical physics, and there's a lot we don't know about these monsters. So, let's start harassing a giant vacuum cleaner. But wait, it's not a vacuum cleaner. It doesn't actually suck things into it. They simply fall in, and it pulls them closer using gravity. Okay, no, shut up. It sounds cool. First up, let's throw some spaghetti in there. Well, not much happens. The black hole just stretches the spaghetti out like, spaghetti, and eats it up. The interesting part, though, comes from our perspective of watching the spaghetti fall into the black hole. From our perspective, it would look like it stopped, then got redder and redder until it faded away. No, I didn't smother it in marinara sauce. The reason this happens is light is still coming from the point where the spaghetti crossed the event horizon until it becomes too redshifted to see. I'll explain what an event horizon is in a second. If we could see it, though, in theory, we could see everything that ever fell in, even the star it came from. Okay, cool. But can we blow it up with spaghetti? No, we can't. Here's why. Black holes don't care how many things we throw at them. They'll just eat it as soon as it crosses the event horizon. I should probably explain what that is now. The event horizon is the point of no return when you fall into a black hole. It's also the thing that we observe when we look at them. Whether it's matter, like our spaghetti, or energy, like electricity, because of Einstein's E equals mc squared, any matter or energy that enters the black hole only increases its mass. But what if we threw in so much spaghetti, the black hole got overfed and the event horizon wouldn't trap things anymore? The singularity, the thing in the middle that everything falls into eventually, would still be there, but as long as you didn't hit it, you wouldn't die. But that wouldn't work with our spaghetti because we need something with a little mass and a lot of charge, so it either spun too fast or got overcharged. Even if we could do this, eventually the black hole would reject the things we throw at it, because only so many things with the same amount of charge can be in the same space at the same time. Opposites attract, and the same things, well, don't. Same thing with spinning it. Once it gets to the limit of spinniness, it won't take more spin. Some scientists think that if, right before the black hole reaches its limit, we throw the right amount of things in the right way, we might be able to do this, but many are skeptical. However, if we did find a way to destroy the event horizon, we'd break physics. Singularities aren't technically in front of you. They're in your future, since black holes warp space and time so drastically that they switch roles. This causes a lot of problems. I won't get into all of them now, but basically, be grateful we have black holes to protect us from the absolute madness of singularities. Now how about we throw something a little more important in? This guy. Let's name him Bill. What would Bill's experience be in the black hole? As he got closer to the black hole, Bill would see himself. The reason for this is that even light can orbit a black hole. So the light from the back of his head would orbit around to meet his eyes, so if he looked straight forward, he'd see the backside of himself. Eventually, if we're talking about a smaller black hole, since his feet were towards the black hole, he'd go through spaghettification. Now, I couldn't exactly represent this on the computer because I couldn't figure out how to stretch the image because Boomer Kristen. But gravity would pull on his feet more than his head, and he'd eventually get reduced to a thin stream of plasma and reach the singularity. However, if you went into a supermassive black hole, like the ones in the middle of galaxies, Bill here could look back as he crossed the event horizon to see his window to the universe getting smaller and smaller. Unfortunately, even though he's not dead yet, any direction he moves sends him towards the singularity. Remember, the singularity is so messed up as far as space and time that it's just in his future, not in front of him. Time is so warped for Bill here that he could actually time travel, which is another reason why it's good for us to have event horizons to protect us from a whole slew of paradoxes and insanity.
Wait a moment. Where did you get that peach?
Someone threw it at you earlier.
But that someone was me.
I know.
But where did I get it?
From me.
Yes, but where did you get it?
Someone threw it at you earlier.
But that someone was me.
I know.
But where did I get it?
From me.
Yes, but where did you get it?
Someone threw it at you earlier.
But that's
You're welcome. Eventually, Bill would be lost to the singularity, which makes everything technically equal and condenses it into a point that is infinitely small. But all of this is theoretical black holes that don't spin, and scientists expect that all of them spin. That makes the math a lot harder. To quote Kurzgesagt, or Kurzgesagt, I'm not exactly sure how you pronounce their YouTube channel name, but they said that this means that, in reality, black holes are even more screwed up than they usually get credit for. So that means that singularities get squashed, sort of, if you can imagine a thing with no height or width getting squashed, by the spinning of the black hole, and they turn into ringularities of sorts. Before we break our brains further, I'll move on. Now, what happens if we throw sound into a black hole? Now, I couldn't find anything on this topic, but I concluded that since black holes swallow everything, both matter and energy, remember our spaghetti example, that they would just eat up the sound too. However, I have found a clip of the alleged sounds a black hole make, both the black hole itself and two merging. They interpret this using radio waves, and I'm not sure exactly how they do it, but here's what it sounds like.
The low, eerie howl of a supermassive black hole in the middle of the Perseus galaxy, the sound of two black holes merging. Yep, that's it. Here, I'll let you listen to it again.
Can we blow it up with sound, though? Well, no, because it would just absorb the energy. Here's another fun thing to throw in. Antimatter. Antimatter is the evil twin of normal matter. It deletes normal matter because they're opposites and cancel out. The problem with throwing antimatter into a black hole is there isn't one. Black holes don't really care what they're eating as long as they're eating it. Black holes just take in everything, antimatter or not. Well, that's all the time we have for today, folks. I hope you enjoyed this journey of throwing things into black holes and maybe learned something. I don't know, I just work here. Bye! Hi there, hello. These are my MLA-styled works cited for science class. I hope you enjoyed the video, and this entire thing will also be in the description. I will likely do a part 2 sometime because I had a whole section of script that I had to cut out. So yeah, stay tuned for that, and I will see you later. Bye!